Hello, and thanks for tuning into this session on hosting and scaling service-based applications on Azure. My name's Mark Allan, and I'm an Azure MVP. I'm a freelance developer and sometimes a cloud application architect, so I tend to look at Azure through a developer lens. So today we're going to be talking about how to build and host service-based applications on Microsoft Azure. So we'll be going through, first of all, what we mean by a service-based application and why we might want to build one of those. Then we'll talk about the ways you can implement services for your architecture and your application. Then we'll get into the interesting bit about all the ways you can actually host those services on Azure and get them to scale appropriately. And then at the end, we'll wrap up by going through all the options and when you might choose to use them. Right, so what do we mean by services in a service-based architecture? For the purposes of this session, really we're just going for a very simple definition. They are just individually deployable and individually scalable components. So, for example, if you had a canonical e-commerce website, you might have one service which is your actual website, and then that service will be talking to a catalog service to get its product information out. It will maybe have a recommendation service to list the products that you might be interested in. When you find a product you're interested in, you'll add it to the cart using the cart service, and then at the end you'll go check out. The checkout service will talk to the cart service, and you'll then send off payment, arrange shipping, send off emails. So you've got your application split out into lots of little different services, and they will communicate with each other, as you can see using these arrows, by some mechanism. That will generally be via a REST API or via some sort of messaging queue, for instance a service bus. And the reason you do that is to decouple all the services from each other. That provides you with resilience. So for instance, if your checkout service has a fault in it, then your website doesn't go down at the same time. It provides you with an amount of flexibility. So if your recommendation service is AI based and needs some sort of AI service running in a Python library, then you can use Python for that service even if the rest of your service is in .NET. You can reuse your services across different projects. So the email service here, for instance, that may well be something that you would be wanting to reuse in a different application entirely. And importantly, from the point of view of this session, each of those services can be scaled up and down individually, which makes use of the elasticity of the cloud. So for instance, on a normal e-commerce website, you'll find that your catalog service, your product service, is going to be a lot more busy in general than your checkout service. So if you were running a traditional monolithic architecture, then as your catalog service got busy, you'd be also providing more capacity to the checkout service than you necessarily need. Right, so if we've decided that it's a good idea to run a service-based architecture, how do we actually implement those services? The most likely situation is that you'll be running a container-based architecture. That's been quite popular for the past few years. There has been quite slow adoption in the Microsoft side of things. That's mainly because containers have been generally a Linux thing until quite recently. The basis of Docker and potentially other container architectures is features of the Linux kernel. So it's only been relatively recently that Windows has been able to run in a container, and obviously prior to .NET Core, your applications, if you're running .NET, had a dependency on Windows. So in the Microsoft development side of things, you're most likely got a Windows dependency. But more recently, .NET Core has come along, which runs on Linux, and Windows containers are now getting to a state of maturity where you can actually use them in anger in production on things like Kubernetes. So what is a container? It's essentially your application packaged up for deployment, including all its dependencies. So you build up in layers your container, which contains the operating system layer, the dependencies, and your application. And then you can connect your containers to each other by exposing network endpoints. You can use storage outside the container using storage volumes on whatever host you're running it on. And the point about this is that you can wrap everything up, and you know that if you've been doing something in development, you can then deploy that to production and it will run exactly the same, because whatever you're hosting it on, in theory, does not matter. So if it runs on your machine, it will be the same in production. You can sort of think of it like a very lightweight VM. Now, that's not actually how it works at all in practice. Unless you're using Hyper-V in particular, then you don't get any sort of security boundaries in the same way as you would with a VM. But from an implementation point of view, you can think of it very much like that. Now, if you're not using containers yet, you might just want to run traditional processes, normal executables, and you can certainly do that in Azure as well. In particular, you might be interested in using the actor model. That's quite a popular pattern. It was originally invented in the 1980s in Ericsson to run their telephony switches. How actors work is essentially you have isolated threads as your processes, which don't get outside themselves and purely communicate via message passing. They will create child actors, manage those child actors, and the actor runtime will handle when those actors fail. It will bring them up and down, and they're self-healing and highly reliable, in the same way as Java was described as write once, run anywhere. One of the inventors of the actor model, Joe Armstrong, actually described it as write once, run forever, which is quite a nice way of thinking of it. And the other popular way of running services, of course, the new hotness, is functions as a service, sometimes just referred to as serverless. Certainly was the original use of the word serverless. And what you're doing there is you are literally just taking a function, as it says on the tin, with inputs and outputs. You're running that on some tin somewhere, but you don't care what it is. That's why it's called serverless. You don't care about the server. And your functions just run the code for the amount of time that they need to run and trigger each other, so they're just ephemeral. They sort of live briefly, die again. Event driven, so you just call into them when they're needed. And what you get out of that is you get a very low management and very low cost and quite high flexibility, very high speed of scaling, and that sort of thing. So those are the main ways to implement your services, at least currently. Now we'll go into the Azure side of things and how you would host those services. Be aware that this is constantly changing, so if you're listening to this session as recorded, keep an eye on the timestamp. Some of this may well have changed in the meantime. Right, so first off, we'll suppose you've got a website, and that website uses a third-party DLL to generate PDFs. Now, Azure originally was developed, as you may know, as a pure platform as a service solution. So there were things called web roles and worker roles, and what those did was they gave you a platform to run on, which included the operating system and web server, and you just gave the code and general .NET code to run on top of that. But the problem is that when you're tied down to a platform, it's quite restrictive what you can run. Now, you gain a lot, obviously, in the terms that you don't have to maintain the platforms, so you don't have to worry about the security and upgrades and all that sort of thing. But after a while, Azure had to bring in infrastructure as a service and VMs because not everything worked on platform as a service. And that's been the same until quite recently. What used to be web roles and worker roles are these days packaged up in what's now known as Azure App Service. And the new thing that's now come along is what's called Azure Web App for Containers, which is containers being able to run on Azure App Service. So what you can now do, you can take your code, you can deploy that into a container image. You can push that container image up to a container registry, which if it's public might be Docker Hub, or if it's private more likely will be an Azure Container Registry. And now you can link your app service, your web app for containers, to that registry and tell it to run that container image. And thereby you can run your application with its dependencies in Azure App Service. And what that gives you is it gives you this, all the benefits you get from App Service and Platform as a Service. So you get the scaling ability. You can scale based on the amount of CPU and memory that you're using. You can tell App Service to spin up extra instances when you go over a certain amount of CPU usage, for instance. You can tell it to run a minimum and a maximum number of instances, how quickly to scale up and down. But you still get those benefits of developing using containers, so you still get that development to production workflow where you know that you don't have a different set of dependencies or a different environment in the cloud than you have on your development environment. You can also run multi-container apps now, so you can use the same basic configuration as is used in Docker Compose, which is the standard Docker way of linking together containers. So for instance, if you had sort of a WordPress and MySQL, you could have a WordPress container and a MySQL container both living together. Or you can sometimes have what's known as sidecar containers, so you would have your application in one container, but you may, for instance, have a separate container which provided logging. And since that now supports Windows, it's now a great option for lifting and shifting your current applications. So getting them off infrastructure as a service or even your own personal data centers or server rooms and getting them out into the cloud nice and easily. Okay, so we've got our website up and running in the cloud. Now let's suppose that we have another service that we want to run, which is a background processing service that runs for a while and then stops again. We wouldn't want to run that in web app because we really just probably only want to run it for a few minutes, and we really don't want to be pulling up a whole app service and then tearing down the app service at the end of it. And this is where Azure Container Instances comes in. Now from a development point of view, we're looking at something very similar. We write the code, we deploy that code to a container image, and then we push that up to a registry ready to run. Now, the difference here is that when Azure Container Instances is running, we are running just a very simple, lightweight, on-demand container. So just one container. Now, the difference here is particularly that it's just a very quick and simple bring your container up, run the container, tear the container back down again. And that will just be priced by memory and CPU or GPU if you're running, for instance, an AI workload. And that will purely charges then for the amount of compute that we need to do to run that job. There's some integration there with Azure Files, so we can save off our results of our output to Azure Files. But it's important to note here that we really are at the very simplest level here. So there's no built-in scaling. We have an image, we tell container instances that we want to run that container, it fires it up, it runs it, it brings it back down, that's it. Nothing more, nothing less. So as I said, good for something that you want to run for a short time, at least when it's all by itself and not combined with anything else. Now, similar thing here, but different. Imagine you've got, for example, a whole load of IoT devices out there, and at the end of the day, you pull in all the data from those devices, or you've been pulling in that data all day, bit by bit, but you then want to collate that information and do some end-of-day processing to produce some sort of output for working out what's going to happen during the next day, for instance. And that's where Azure Batch comes in. The way Azure Batch works is you give it just a sort of potentially huge queue of tasks to work through, and those tasks are just documents, usually in blob storage. What Azure Batch will do, it will allow you to run up a pool of compute nodes, so VMs, and into each of those compute nodes you can feed a process or a container. So that's always the same process and the same container, but you can scale that as wide as you want, and your process can then chew through that queue of tasks as quickly as it can until all of them have been processed. So this is great for running massively parallel workloads. You can scale the number of nodes in your worker pool there based on potentially quite complicated formulae based on the number of outstanding tasks that are running, how much load is currently running on your VMs, on your worker nodes. The other thing it can do is you can tell it that you want to run on what are known as low priority nodes. So in other words, if it's not urgent that your processing happens right now, but you just need to get it done at some point, then you can tell Azure that it's fine to wait around until VMs elsewhere or compute nodes elsewhere are idle, nobody else is using them, and then it can use that spare capacity to run your processing job. So that's kind of like container instances in some ways, but if you want to run loads of them at the same time. Right, so those so far have all been about running one container or one group of containers at a time. But really we want to be heading for the full service-based application that we were looking at earlier, and that's where Azure Kubernetes Services comes in. Unless you've been living under a rock, you'll have heard of Kubernetes. It's Google's open source container orchestration solution. There are other container orchestrators out there, things like Docker Swarm and Apache Mesos, but these days Kubernetes is kind of the de facto standard, and you have to have a particularly good reason not to go for Kubernetes for container orchestration these days. So, of course, Azure now has that available, and it's available as a managed service. So, for a bit of background here on what Kubernetes is and what it looks like, you have a master node, which is the core of Kubernetes. So that's always there, and that's what does the main Kubernetes processing. So in that master node, you've got an API, which is what you will talk to either using the command line interface, kubectl, or potentially directly using REST, and that will allow you to define what it is that you want to run. You then have the controller manager. What the controller manager does is to look at the current state of the system and then at the desired state of the system. So what you do is you will generally define the state of the system using a big pile of YAML, similar to the way that you might use ARM templates to define the state of an Azure deployment in general. And then as time goes on and you maybe want to scale things up and down or change things through the API, the controller manager will watch the current state of the system, what the changes are for the desired state of the system, and make that all happen. So tell the worker nodes to bring in new containers, to take down containers, to change the version of containers, and all that sort of stuff. The scheduler there is what's responsible for assigning pods to nodes. And what are pods? Well, when the controller manager and the scheduler are creating nodes, which are essentially VMs, each of those nodes gets created with what's called a kubelet. And that kubelet is responsible for creating pods. And those pods are what contain the containers or container groups that make up your services. So as you grow, you get more worker nodes, and the kubelets are responsible for distributing your service containers around the pods in the various nodes in the most efficient manner. You also, in your worker node, will get a C advisor, provides you with metrics for performance and usage. And when somebody actually accesses service, whether that be from an external source or from one of your other services, the service requests will come through the proxies that are in the worker nodes, which will then work out the right pod to go to according to the service that's been requested and the load balancing required, which obviously is all defined inside your API and large pile of YAML. Azure itself provides for you most of this infrastructure. So it will provide the master, which will come with all the Kubernetes stuff loaded up into it. It will obviously provide the VMs for the worker nodes. It will provide all the networking for you. And so you essentially just end up providing the containers that are and the configuration through the API, which system. So Kubernetes comes, as you can see, with an awful lot of power, depending on what you put in there. And with that power, obviously, comes great responsibility. You can get a relatively simple Kubernetes cluster running up without too much difficulty, but once you get beyond the basics, then there's a lot of weeds that you can get into, so it can get to the stage where it's really not for the faint of heart. On the other hand, if you are using Kubernetes, then there is a huge, vibrant open source ecosystem, so you'll get a whole load of tools and tutorials and examples going on the internet. In particular, Microsoft are deeply involved in what's called Helm, which is kind of a package manager for Kubernetes. So in keeping with the general nautical theme of naming that goes on with anything to do with Docker, you can get what are called Helm charts. So if, for instance, you wanted a Cassandra database as part of your cluster, you could download a Helm chart, which you could use to stick that database into your cluster. If you wanted a ready-made auto-scaling strategy, then you could similarly download an auto-scale Helm chart to stick in. So you can get a lot of help with this, but it does still get potentially quite complicated. Nice thing about running Kubernetes on Azure is that there is no cost for anything apart from the worker node. So you're only paying for compute. You're not paying for the master node. You're not paying for Kubernetes itself. You're just paying for, again, the amount of CPU and memory that you're using for the VMs. Windows containers are also now supported as of a couple of weeks ago by Kubernetes, so there is no need now not to use Kubernetes for any of your container strategies where you need orchestration. It's still not quite as well supported as Linux. There are various features which aren't provided for Windows, but it is now supported as a production workload. One thing that Azure brings to Kubernetes exclusively is what's called virtual nodes. So where you would normally be bringing up VMs for nodes, a recent addition has been to be able to spin up instead a virtual node, and your pods then link to Azure Container Instance containers. What that gives you is much quicker and more responsive and elastic scaling where that's necessary. So rather than having to wait for a full VM to be run up, you can fire up a small number of containers or a large number of containers using Azure Container Instances, run those for as long as you need them, and then quickly run them back down again. So that gives you that elasticity and also potentially the cost savings of not having to run up a whole new VM and leave that sitting around. You can just get that fine-grained charging. Okay, so moving on from containers for a while, what about running services as processes? Azure Service Fabric, it's quite similar to Kubernetes in a lot of ways. Kubernetes was built by Google out of some of the work they'd done for their own internal orchestration of containers. Service Fabric was built by Microsoft as an orchestrator for their own Azure services, and again, sort of was public version was produced of that. Kubernetes has a cluster of nodes running containers. Service Fabric has a cluster of nodes running, in our case, processes. What Service Fabric also gives you is SDK support. So if you're running a .NET process, then you can use a .NET package or .NET packages to provide extra support for the fact that you're running on Service Fabric and to make use of some of the extra features from that. So this is an architecture diagram of Service Fabric. Now, most of this is fairly much, sort of similar to what's running on Kubernetes. So you've got your networking, you've got your node management, you've got your hosting and reliability and networking and management. So all have to a certain extent sort of similarities or parallels with Kubernetes. This bit here is the interesting bit. This is the application model. This is what I was saying. If you're running .NET services, then as well as the orchestration, you're also getting a development platform. So you get things like what's called reliable collections. So if you've got a key value dictionary, but you want to share that between different instances of your process as if it was the same, reliable collections gives you an in-memory collection for each process, but it gives you invisible syncing between all the instances of your process. They all get the same data at the same time. You also get what's called reliable actors, so that's what allows you to run the actor framework on Service Fabric. So if you have one of those utterly bulletproof systems that you want to run, Service Fabric is a good choice for that. You can actually run containers on Service Fabric as well, more recently, but I would be honest, since Windows container support came into Kubernetes, you probably would be better off using Kubernetes for container support. It's not exactly an afterthought in Service Fabric, but it's just not as strong or as mature. There's not the ecosystem around it. So if you want to orchestrate containers, I would not personally use ServiceFabric, to be honest. But if you're writing .NET processes, then certainly it's a very, very valid option for you. And if you're writing .NET or indeed any other sort of code, then of course Azure Functions is something you should definitely be looking at. The whole serverless way of building things that's now coming into vogue for very good reasons. So Azure Functions, it's very different to the way you might be building your applications at the moment, even if they are service-based. The thing about Azure Functions is that they are entirely event-driven, which is difficult for lifting and shifting, but gives you a lot of power, and gives you the full use of the cloud. So here, for example, we've got a little example of something that you might have built. So if you've got again a load of IoT devices, so those will send messages into Hub, and every time a message comes into IoT Hub, it can be sent off as the input to an Azure function. So that effectively, in your function, say you're writing a C# or a JavaScript function, that will actually come in, that message, as an input parameter to your function, or your method if you prefer. That will then run for a hopefully fairly short amount of time, and then that can potentially produce one or more outputs. So we might, in this instance, decide that we want to save everything that comes in, having been checked and transformed, into a Cosmos DB collection. But then what we can also do is we can use the change feed feature of Cosmos DB to trigger off more functions. So we might run another function that saves information off to Azure Blob Storage or to some other form of more cold storage. We might run another function that sends off an output notification hubs to send, for certain messages, a notification back to the device. And of course, we could then also say for certain messages we want to send a message to Service Bus, which can then trigger off more events of its own, either more Azure Functions or anything else that might be subscribing to your Service Bus. Now, the great things about Azure Functions are, again, you're paying for usage, but because you're at such a fine-grained level here, you are triggering it a function, the function runs, the function disappears. So in the same way as Azure Container Instances gives you that fine-grained responsiveness, Azure Functions give you even better fine-grained responsiveness. Something happens. You run just what you need to run to handle that event. You send off something, your function closes down. And even though your function's immediately available as a general rule, you only pay for exactly the amount of time and CPU that function took to run. You also get, at the moment, 1 million function invocations per month for free. So what you're getting here is, on the standard consumption plan at least, a highly responsive, highly scalable, almost infinitely scalable, and pay-per-use processing system. So for anything that you can build that's event-based, you should certainly be considering Azure Functions. The functions you can run at the moment are C#, Java, and Node. There are also in preview PowerShell. I have no doubt that there are more languages coming down the line as well. The original version of Azure Functions 1, had reasonably wide language support. They rewrote the way it works for Functions 2, so we've cut back to just those 3 there at the moment. But hopefully most of the languages will be coming back. You also get what's called durable functions now. So as well as just the ephemeral functions which are essentially stateless and just run up, do something, and then disappear again. Durable functions allows you to orchestrate those in a serverless manner. So suppose, for example, that you have a whole load of functions that run, and when all those functions are finished, then you want to take the outputs from all those functions, bring them all together and continue processing the combined output. That's where durable functions comes in. You can run a single orchestrator durable function, which, although it is a real Azure function and so only runs briefly, it will then keep polling, so hardly costing you anything at all, for the functions that it kicks off until things are ready, and then it will continue on using the output from those functions. And if you're running C#, for instance, that just looks almost like an await function. So you can await an Azure function from a durable function, await several functions, and then move on with the output as required. You can also use that for situations where, for instance, you want to wait for some sort of manual process to be invoked. As I've mentioned, you will not, as a general rule, be able to lift and shift your current code out to Azure Functions. What you can do is to take things like individual portions of your code, probably. So small jobs that don't run for very long can be moved out to Azure Functions. Small services, something like an email service, you could probably lift that out and just have that triggered that when you want to send an email, you trigger a function and the function sends the email. But you're certainly not going to be able to lift and shift your entire system in the same way as you can with containers. Okay, so we've established that serverless is great for insulating you from the implementation details so that you can just take your code, upload it to Azure, and it runs that code without you needing to worry about what servers are there, and it scales as large as you need and as small as you need, and it only charges you for the amount that you use, which is great. And it would be really nice to have that for containers. And that is where Azure Service Fabric Mesh comes in. What Service Fabric Mesh gives you is a serverless container orchestration platform. So you feed it containers, it runs the containers, it abstracts from you all the stuff under the covers in terms of storage and platform and security, and just basically runs the containers, as many instances as you need to handle the workload that's coming in, and only charges you for the amount of time that you're running them. It's called Service Fabric Mesh, but to be honest, Service Fabric doesn't necessarily need to be involved at all here. So the whole point is that it abstracts the platform from you, so this could equally have been running on Kubernetes, or it could be running on some other orchestration platform that Microsoft have invented. The whole point here is that you give it containers and it runs them. So at this point we're in a public preview. It's trying to be serverless. It's not quite there yet. But what it does do is to get rid of that complexity. So, you could get a similar sort of effect by running Kubernetes with the virtual nodes and the Azure Container Instances, but you still have to deal with the configuration of Kubernetes. All you really have to do with Service Fabric Mesh is to configure in the same way as you would do with App Service, then sort of the number of the minimum and maximum number of instances, and how you should scale those containers up and down according to their CPU and memory usage. It will handle the provisioning of those instances, it will handle the networking between them, and it will handle the integration of the Azure services that you might need to work with. as they continue to build this out, I would like to hope that sort of this will become even more transparent until you get to the same sort of level as the consumption plan in Azure Functions, where there is basically no configuration to do. But for now, it's a pretty good start, so it's certainly worth looking into. And finally, if you've been building your service-based application and you want to attach it to some external services. If anybody's used Microsoft Flow, then this is basically Microsoft Flow for developers. What it gives you is of the order of 300 custom connectors that you can hook together in a workflow. And that workflow can also include custom code like Azure Functions or your own custom connectors or triggers coming in from webhooks. So you can see a small example in the slide there of some of the connectors that are involved. So for instance, if you wanted to do something when a charge is made using Stripe, you can connect on the Stripe connector and it will trigger one of your Logic Apps. If you want to upload a file to an FTP server, you've got some FTP. Easily add those to your workflow to connect to your FTP server. If you want to upload a file to an FTP server when a charge is made using Stripe, you just make a single Logic app with both of those connectors in, and hey presto, you could actually do that with no code. So it's a very powerful platform. You can build entire workflows with it yourself without having to write any code of your own if you want, and sort of a lot of business users could actually build things like this using Flow, which is the sort of the consumer facing version of this, as it were. But it's great for integrating with those third-party services and building your own little workflows which can hook off the end of your existing app. Nice thing about it is, for instance, if you're talking to Stripe there, then you only have to authenticate once when you set up the connector, and then that's all handled for you, so you don't have to fiddle with OAuth. And looping back to the start, the Azure Logic Apps is also hosted on App Service, so back to the old web roles and worker roles from the very, very start of Azure. So this is the summary of what you would use in what situation. So if you just want to do a lift and shift, then your best bet is probably to stick it onto App Service, onto Web App for containers. If you've got simple workloads, put them in a container and put them into container instances for short-lived jobs. If you're building something new, then certainly try to make it event-driven so that you can use Azure Functions, because that'll be by far the most scalable and efficient use of resources. If you aren't going greenfield, or if you want to go use containers for portability, then you can get the full power of Kubernetes in Azure Kubernetes Services. If you want to use processes, you'll be wanting to go for ServiceFabric, and if you want to get the power of serverless with the convenience of containers, then certainly do keep an eye on ServiceFabric Mesh. That is I would suspect going to be where a lot of the effort goes in the near future in terms of containers on Azure. Between that and the Kubernetes virtual nodes. Use Logic Apps to sort of build your own workflows and integrations, without having to faff around with stuff. And the last thing is, don't be afraid to mix and match these. Any of these can hook, can hook in with any of the others, really. So if you have a website that's best lift and shift to App Service, but you've got then new services that go into AKS, and you've got Azure Functions workflows, then that's a perfectly legitimate solution. And that's everything. Obviously I can't take questions because this is a recording, but if you do have any questions, then feel free to look me up online. I'm MarkXA on most of the online services, and thanks for listening.